NDE methods: ultrasonic multi-skip, creeping head wave method, advanced ultrasonic techniques for material inspection. Principles of creeping head waves, chime, multi-skip propagation concepts. Creeping head waves form the scientific basis of the chime method, a specialized ultrasonic screening technique used for detecting corrosion and degradation in pipes and plate structures. This method relies on the interaction of ultrasonic waves traveling along surfaces at critical angles, enabling long-distance coverage between transmitter and receiver probes. According to the chime inspection methodology, ultrasonic transducers mounted on angled shoes generate both bulk and creeping waves, which propagate along internal and external surfaces, acting as natural waveguides. This propagation is advantageous because attenuation is minimized, allowing reliable inspection of large or inaccessible areas without requiring surface removal or significant disassembly. The wave phenomenon is rooted in critical angle refraction, where waves transition into lateral or head wave modes capable of traveling considerable distances. These wave interactions allow screening of structural wall loss, cracking, and general degradation by monitoring signal arrival times, amplitude reductions, and waveform distortion. As reported in chime technical documentation, this approach is particularly suitable for components under clamps, supports, or saddles and has demonstrated successful performance in both upstream and downstream petroleum operations. Overall, chime fundamentally depends on exploiting wave physics to overcome access limitations in industrial assets. Multi-skip ultrasonics, M-skip, expands on the wave-skipping behavior observed in creeping and head wave modes by enabling ultrasonic energy to bounce multiple times between internal and external surfaces. This pitch-catch technique places probes on opposite sides of obstructions, allowing indirect examination of hidden pipe surfaces. The wave reflections create predictable travel paths, and the measured arrival times provide accurate wall thickness data. M-skip is valuable for circumferential and axial inspections, even in complex geometries such as pipe-to-bend transitions and saddle supports. It delivers higher precision wall loss sizing than amplitude-based methods because thickness is computed from timed propagation rather than signal attenuation. Field experience shows that M-skip provides uniform wall thickness accuracy within plus or minus 0.1 mm and localized wall loss accuracy within plus or minus 1 mm under certain conditions. Its reproducible signal fingerprints make it useful for long-term condition monitoring. By combining near-field skips, far-field skipping, and creeping head wave propagation, this method provides comprehensive coverage of otherwise inaccessible regions without requiring direct access to the inspected surface. Large area screening in pipes and vessels, screening inaccessible and complex geometries. Ultrasonic multi-skip and creeping head wave methods are used extensively for large area corrosion screening in industrial assets such as pressure vessels, pipelines, and separators. Conventional ultrasonic inspection often requires point-by-point scanning or grid-based thickness mapping, which is both time-consuming and sometimes inaccessible due to supports, clamps, and structural obstructions. Chime and M-skip overcome these limitations by enabling long-range wave propagation between two externally positioned probes. As documented in chime field applications, this method provides coverage of the entire volume between probes separated by up to 1 meter or more. This capability enables operators to perform initial corrosion assessment quickly, identifying areas that require detailed follow-up inspections. The ability to inspect underneath saddles, pipe racks, or clamps without disassembly reduces shutdown costs significantly and improves inspection efficiency. Furthermore, this method supports both upstream and downstream facilities, offering versatile applicability across complex plant environments. Many industrial assets include components obstructed by structural supports, insulation, clamps, or welded attachments. Traditional UT methods require physical access to the region, often necessitating removal of supports or lifting of piping systems, which is costly and may introduce safety risks. The multi-skip technique allows probe placement on either side of an obstruction, enabling ultrasonic waves to propagate beneath or around the object through multiple reflections. Because creeping and head waves utilize the material surfaces as waveguides, they can navigate around bends, transitions, and geometric complexities. Field trials referenced in industry evaluations demonstrate that chime and M-skip methods are capable of inspecting saddle-supported pipe segments, clamps, and various inaccessible areas while retaining sensitivity to corrosion damage. These methods have become widely accepted in plants seeking rapid screening solutions for hard-to-reach regions, especially when the alternative requires significant mechanical intervention. Relevant ultrasonic testing standards. While chime and multi-skip methods are specialized ultrasonic techniques, they operate within the broader framework of nondestructive testing (NDT) standards. Although not always codified as standalone methods, they reference principles found in UT terminology and calibration standards. International standards organizations such as ISO and ASTM maintain evolving guidelines that improve the reliability and consistency of ultrasonic inspections. Recent revisions to ISO 7963, calibration block specifications, and ISO 16946 help ensure better accuracy in reference blocks and systematic verification procedures. Additionally, standards such as ISO 23864 and ISO 23865 address advanced ultrasonic imaging methods and testing protocols, reinforcing methodological rigor even when applied to creeping head wave or skip wave inspections. These frameworks provide harmonization across industries and support consistent data acquisition, interpretation, and reporting. Probe positioning and setup, signal analysis, and defect identification. The effectiveness of ultrasonic multi-skip and chime techniques depends heavily on proper probe positioning and angle control. Transmitter and receiver probes are typically mounted in pitch-catch configurations, with transducers placed at specific distances determined by material thickness, geometry, and expected skip patterns. Angled shoes generate ultrasonic waves at or above the critical angle, enabling creeping, head, and skip waves to propagate along surfaces. Probe separation distances, wedge angles, and coupling quality significantly influence inspection sensitivity. Operators must ensure consistent coupling and alignment to avoid signal misinterpretation caused by geometric reflections or mode conversion effects. In practice, encoded scanning systems or manual fixtures may be used to maintain alignment and repeatability. Understanding the propagation paths allows inspectors to differentiate between normal skip reflections and reflections caused by corrosion, pitting, or cracking. Signal interpretation in multi-skip and creeping head wave inspections relies on analyzing the arrival times and amplitudes of ultrasonic echoes. Since the method is primarily time-of-flight based, wall thickness changes manifest as variations in skip path duration. Corrosion or wall thinning reduces the distance between surfaces, resulting in earlier arrival times and potential amplitude changes. In addition, localized defects such as pitting may distort specific segments of the waveform or attenuate the creeping wave component. Chime method research indicates that head waves and lateral waves produce characteristic signal groups that can be used to distinguish wall loss conditions from geometric reflections. Combining multiple skip cycles further enhances defect sensitivity by producing multiple independent travel paths through the same region. Advanced software tools may reconstruct simplified C-scan style maps showing areas of concern. This makes the technique highly suitable for rapid screening prior to detailed UT or phased array mapping. Field demonstrations and HOS developments, industrial adoption of multi-skip methods. Field trials conducted under HOS, Harwell Offshore Inspection Service, initiatives have validated the practical performance of the chime method across a wide range of industrial applications. These studies documented successful screening of corroded pipeline samples, verification on plate structures, and real-world deployment on refinery piping systems. Technicians reported satisfactory sensitivity to both general wall thinning and localized corrosion profiles. The ability to screen long distances between probes and to inspect under supports proved especially valuable. Moreover, the method demonstrated good repeatability across multiple trials, forming the basis for continued development and wider acceptance in asset integrity programs. These findings underscore the method's importance in reducing inspection time, enabling early detection of degradation, and improving the overall maintenance strategy. The multi-skip method has seen increasing adoption in offshore and petrochemical industries, particularly for inspections involving pipe supports, clamps, and other inaccessible regions. As documented by offshore inspection providers, MSkip offers advantages in both detection capability and measurement accuracy for general wall loss conditions. Its permanent digital record and reproducible signal fingerprints make it ideal for monitoring long-term asset degradation trends. Combined with other long-range screening techniques, MSkip is often used as a complementary method to provide comprehensive coverage when conventional UT and guided wave systems fall short. Many operators now incorporate multi-skip inspections as part of routine condition monitoring and risk-based inspection programs, citing efficiency, cost reduction, and improved data reliability.